As we go on to topic 7 of chapter 5, here we're going to deal with the sum or differences of cubes. And there is a recipe for doing this, and we can also deal with some equations in which they're used. So let's take a look at these. Raise this up a little bit. So let's start with the general background of this. So if we have something like a to the third plus b to the third and a to the third minus b to the third, this would be the sum of perfect cubes. This would be the difference of perfect cubes. So we're looking for a way to factor them. And there's a recipe, and it's very similar for both of them. And what we do, we make a parenthesis for 2 terms and a parenthesis for 3 terms. And we'll do the same thing here. Parenthesis for 2 terms and a parenthesis for 3 terms. Now, whatever sign is here, whether it's the sum of or difference, this is the sign you put there. Now, everything else is positive except over here in the middle term of the 3-term parenthesis. Whatever sign you put there, it's the opposite sign there. This is negative, so this will be the positive. All the others are positive. So this is part of the recipe. A parenthesis for 2, parenthesis for 3. Whatever sign is there goes for the 2, and then opposite sign in there. Then we take the cube root of this, which is a, the cube root of this, which is b. And this is the same for both. Now from here it's the same. We square this term, square that term, multiply these 2 terms together. This is a times b, so you get ab. Now you might say, well, isn't that supposed to be positive? But remember our recipe. This sign here, opposite sign there, and that is true. These are the correct signs, and we can't use the rule that we normally do. So again, multiply these together, goes there. Now you're going to square this term, and that becomes b plus. Square this term, b plus. And there is the factoring of the sum of perfect cubes, the difference of perfect cubes. Very similar. And now let's try some. So parenthesis for 2, parenthesis for 3, parenthesis for 2, parenthesis for 3, parenthesis for 2, parenthesis for 3. All right, let's just do this row. So sign plus here, that means there's a negative there. Negative here, that means there's a plus there. Plus here means there's a negative there. Okay. Cube root of this is z. Cube root of this is 4. Square this. Multiply these 2 together. Square this. Cube root of this. Cube root of this. Remember, it's just dividing it by 3. So it'll be b to the second. And square this. This will be 4a squared. Multiply this together. 2ab squared. Now square this. This will be plus b to the 4th. All right, the cube root of this is x to the 3rd. Cube root of 27 is 3. Now square this, x to the 6th. Multiply this together, you get 3x cubed. And then square this, plus 9. So it takes a while to, again, write these down and practice the recipe. Now, as we look at this, 54 is not a perfect square. So we're going to have to factor something out of that. In fact, I think we could factor out a 2. And there is an x, 2x. We factor out of this. So this leaves me with a 27 z cubed minus 125 x to the 3rd. Now this is the difference of perfect cubes, and I'll put it down here. So a parenthesis for 2 terms, parenthesis for 3 terms. What sign do we put here? Negative. So over here it's positive. Cube root of this, 3z. Cube root of this, 5x. Multiply these, well, we got to square this first. 9z squared. Now we multiply that together. And again, here we're disregarding the sign because we know here if that is negative, then it's going to be opposite sign there. And this is going to be 15xz. And now square this, 25x squared. Okay, again, this is a perfect cube, perfect cube, perfect cube. Any exponent divisible by 3 is a perfect cube. So, parenthesis for 2, parenthesis for 3. What sign do we put here? Negative. What sign do we put here? Positive. Cube root of that is 4a squared. You're dividing the 6 by 3. And then here, this is going to be a negative b. Divide the 12 by 3. That will be 4. Okay, now we're going to square this. That gives us a 16 a to the 4th. Multiply these two together. That gives us 4 a to the second, b to the fourth, and now we square that, and that becomes plus b to the eighth, because it's b to the fourth times b to the fourth gives you b to the eighth. Okay, here's one with a fraction. It's the sum of perfect cubes, parenthesis for 2, parenthesis for 3. What sign goes here? Plus. Opposite sign there. Cube root of this is x squared. Cube root of that is 1 over 10. Square this is x to the fourth. Multiply these two together, it's going to be x squared over 10. Square this, 1 over 100. Okay, so there's the recipe, and it's not too difficult, but again, through practice, you get to know it. Let's do some equations now. Well, notice it's in standard form, so we're going to factor it. Parenthesis for 2, parenthesis for 3. Negative there, positive there. This is A, this is 3. This we're going to square. Multiply these together, and we square this. And all of that equals 0. Now, we're going to do our A minus 3 equals 0, and this equals 0 as well. But since this is not factorable, we're not able to solve this. So the only thing we can solve is get one of the roots. This is probably going to be some radical or something. So here we're going to get A equals 3. So if A is 3, it'll make this a 0. Okay? So notice A to the third is 27. 27 minus 27 is 0. So this definitely is an answer. Over here, we're going to put it in standard form. 2x cubed minus 250 equals 0. Factor out a 2. And we get then x to the third minus 125 equals 0. So this is 2, and then a parenthesis for 2, parenthesis for 3, and this is a negative here, positive there, x 5, x squared, 5x plus 25. The only one we can use, because if we divide both sides by 2, the 2 cancels out, and we get 5 minus x equals 0, x equals 5. That's our solution. We can't solve this one. It's not factorable. As we look at the last one, I'm going to transpose this to the other side and then set it up in standard form. This is actually to the third. There we go. So I'm going to factor out from this a 3. This will then give me 27x cubed plus 1000 equals 0. This is now the sum of perfect cubes, so we can cancel the 3 out, divide both sides by 3, it just cancels out, and we get a parenthesis for 2, parenthesis for 3. This is going to be a plus. This is going to be a minus. Here we get 3x plus 10. This is going to be 9x squared plus or minus 30x plus 100. We then equate this. 3x plus 10 equals 0. We get a negative 10 over there. Divide by 3. We get a negative 10/3 as our answer for this one. Okay, I kept these last two somewhat short because they're just following a recipe. And hopefully you've had enough examples and you know what to do. Now it's practice, and we're skipping at this time section 5.8. We'll get back to that when we do chapter 8 and tie it into that. So we're skipping it now. We'll get back to it later. Okay, let's raise it up here a little bit. I'm interested to see what they give for answers here. Yeah, they're saying this one is a negative 10/3. This is a 5. This is a 3. And again, the answers are there. Okay, again, as I said, we are skipping 5.8, but we will be starting chapter 6 in our next lesson.